Hello, everyone. In today's demo, we will share how to evaluate LLM applications at scale. I'm Anupam Dada. I'm part of Snowflake AI Research.
Hi, I'm Avinash Joshi, Senior Product Manager at Snowflake.
Here's the agenda for today's presentation. We will start off with an overview of the challenges with deploying generative AI applications, introduce the Snowflake AI Observability product, provide a demo, and then go under the hood to cover some elements of foundations of evaluations for LLM applications and in their instrumentation. In order to productionize generative AI apps, there are several challenges that we need to address around quality, governance, and efficiency of these applications. When we look at applications such as question answering systems, we have to guard against hallucinations, ensure that answers are relevant and complete, that summaries are of a high quality, and also in certain kinds of applications, guard against inaccuracies, for example, in going from text to SQL. Governance includes elements of data governance, ensuring that we have good guardrails for content moderation, as well as security and privacy. And finally, these apps also need to be mindful of cost and latency considerations. AI observability helps us address these kinds of challenges and thereby enhances quality and trust. This involves evaluation and experiment tracking to choose app components that offer best-in-class quality, cost, and latency. Iteration to rapidly understand the failure modes and improve apps. And finally, monitoring and guardrails to maintain apps in production. Let's now get into what the Snowflake AI Observability product offers, and I'll hand it over to you, Avinash.
Thank you, Anupam. Snowflake AI Observability has two parts to it. First is TruLens open source Python package that allows you to instrument your applications, which is a term from the telemetry domain that means ensuring your applications can generate structured traces with spans. Configure evals from the out-of-box evaluations available within TruLens or create your own custom evaluations. And finally, log to Snowflake in either streaming or batch fashion. The second part is the Snowflake's server-side operations that allow you to store these traces in the chosen data lake, run evaluations as a managed service, and finally, out-of-the-box dashboards that allow you to consume the results of these evaluations. TruLens can be used as a standalone package for local experimentation and testing, but when these traces are logged within Snowflake, you get the benefits of storing these traces in a governed environment, run evaluations on scalable compute in a managed setup, and have an easy to use UI to consume these results. Let's understand this better using an example. For this demo, I'll be creating a chatbot that responds to user queries regarding Streamlit. For this, I have created a RAG application that indexes and retrieves context from Streamlit's open source documentation to answer questions about how to use Streamlit. I have iterated on 3 different retrieval strategies while keeping all the other components of the RAG app constant. For the first version, I have written a DIY retriever myself. For the second version, I'm using Snowflake's Cortex Search as a retriever. And for the third version, I'll be combining Cortex Search retriever with context filtering, where I'll be filtering out any context chunk that has context relevance of less than 0.5. In Snowflake's UI, under the AI and ML section, you can see all the different applications that you have registered within Snowflake. You can click into your application and see the different versions of these applications that have been registered within Snowflake. For this application, the three versions that I was just describing are already registered within Snowflake. It already has a bunch of traces that are logged in my data lake. It gives me at an aggregate level the different dimensions that I can compare these different versions on. First is the average duration of my application. And then I have three different evaluations that have been set up to compare these three versions. First is answer relevance. Second is groundedness. Third is context relevance. To evaluate RAG applications, we introduce a concept called the RAG Triad. The RAG Triad is nothing but how to evaluate your RAG application holistically across three different dimensions. First is context relevance, where you're judging whether the context that your app is retrieving, how relevant is it to the query. Second is groundedness, where you're checking if the final response is supported by the context that was retrieved. And finally, answer relevance, which is telling you whether the final response that the app gave is it relevant to the query or not. These three evaluations are powerful in determining whether your RAG application is trustworthy or not, and is it safe to deploy in production. You can see the third version of my application, which is using Cortex Search as a retriever with the filter, is performing the best among the three across all three dimensions. I can click into the app version to dig deeper into individual traces that this app has generated. For this app version, I can see my aggregate metrics on top. And below, there's a table that lists down individual traces for which I'm showing the status, whether the call was successful or not, the input that the user had given to the app, what was the final output which was generated, what was the duration for this particular response, and the three feedback evals for an individual trace. You can then click into this particular trace to look at it even deeper and see for what happened at individual spans for this trace. Now, this being a simple RAG application, there are only two spans, the retrieval step and the generate step. But as your RAG applications get complicated, you can see a granular view of individual spans and how long did each span take. And if you have configured feedback evaluations for each of these spans, you can see them at the bottom, where for individual spans, you can see the score for your evaluation. For example, here, the question was, how do I launch a Streamlit app? The response that the app gives is a relevant response where it's describing in detail how to launch a Streamlit app. And it has a pretty high score of relevance, which is 0.9. Also, these evaluations give you the reason for the score that they have given, where they go into the response provided by the application is clear and detailed, hence the score is high. Similarly, for your context relevance span, you also have a pretty high score, and you can expand that view and see why is that the case. For this particular trace, there were about four context chunks that were retrieved. For each one of them, you can see what was the context chunk, what was the relevance score for that context chunk, and finally, again, the reason why that score was given. Similarly, for groundedness, you can see why was the score, what was the final response, and so you can see that since the context chunks were used in the final response by the application, it has a pretty high groundedness score. So in this way, you can go through what exactly is happening within your RAG application, and if things go awry, you know what to fix. Let's take another trace example to see how would this RAG application perform for a completely out of whack question. Like, for example, someone asked this question: how do I defend myself against bear attacks? Which has nothing to do with Streamlit. So when you click into that, you can see that the answer relevance is 0.2. The reason being The answer that the application gave was, I'm sorry, I don't have the required information available to answer your question, which is a good thing. The RAG application shouldn't be making up answers, but it does give but it's still not a relevant answer. You see that the context relevance chunk that you were seeing in the previous trace doesn't even exist here because there was no context retrieved for this question, which is why you also have a groundedness score of 0. So in this way, you can individually analyze traces to get to ensure that the RAG application is performing as per your expectation. Now let's look at an individual trace and compare it between two versions. So here first, I'm going to compare the DIY version of my app with the Cortex Search Retriever app. I'm going to I see that for some reason, for this particular trace, where the question was, what's the advantage of using Streamlit forms? The answer relevance is very low for my DIY version, but very high for my Cortex Search. You can see that the answer provided by and the only difference between the two is the context chunks retrieved, because both are using different strategies. So you can see that the context relevance is also pretty low for this trace, while the context relevance is relatively higher for the Cortex search based app version. You can see that the context retrieved has for the Cortex search version is it directly lists down the benefit where the app is easier to manage as a developer and provides a frictionless way to create multiple apps, which is a very relevant piece about when you're discussing the advantages of forms and has a pretty high relevant. But none of the context chunks retrieved by my DIY retriever had a high context relevance because they're just coming up with random HTML garbage. So this way you can see that between two versions, how a trace behaves, and you can get more confidence that using Cortex search as a retriever is probably a better idea. Now let's do a similar exercise between Cortex search and Cortex search with filtering. This time I'll use a different trace where the question asked was, how should I use Streamlit toggle? You can again see that the Cortex search trace has an answer relevance of 0.4, while context search with filtering has an answer relevance of 0.9. The only difference again between the two versions is the retrieval strategy. So let's compare context relevance for both of them. You can see that here the average context relevance is 0.53 versus the context relevance here is 0.9. The reason for 0.53 is the context retrieved with the Cortex search, where there were 4 pieces of content retrieved. 2 of them had a 0.2 score, while the other 2 had a 0.9 and a 0.8. So the context search did find correct context to retrieve, but along with that, it also ended up retrieving 2 irrelevant context chunks, which brought down the average score to 0.53 and also affected the final response. While here, because I'm filtering out anything that has a low context score, the only 0.9 score contexts were retrieved, and finally that improved the answer's relevance. So you can see that the final response answer relevance was 0.4 here and a 0.9 here. So in this way, this is a very simple addition to a retrieval strategy where I'm just filtering out low context chunks, but you can build on top of this and build retrieval strategies that can give you even better results. And you can use these evaluation frameworks to ensure that you're going in the right direction. That's my demo. Let's go back to the slides for a second. RAG Triad is a starting point, but that's not the only set of evaluations that Snowflake's AI Observability platform provides. To talk more about it, I'll hand it over to Anupam Datta.
Thanks, Avinash. TruLens provides a comprehensive set of out-of-the-box evaluations to test generative AI applications to ensure that they're honest, harmless, and helpful. The RAG Triad, which Avinash covered in some depth, is in this bucket of checking apps for honesty. Within the harm-related checking, we have support for PII detection, tests for toxicity and stereotyping, jailbreak detection, and more. Similarly, the helpful evals ensure support for sentiment analysis within prompts, language mismatch, conciseness of summaries, and more. One of the distinctive elements of TruLens is that it's also very easy to write custom evaluations that go beyond what is already offered within the out-of-the-box evals. We have talked for quite some time now about different forms of evaluations. Let's go under the hood to understand a bit how these are implemented. A number of the evaluations that you saw, including the RAG Triad evals that Avinash demoed, make use of what are called LLMs as judges. LLM judges are carefully prompted LLM apps that check for properties such as context relevance, groundedness, answer relevance, and so forth. They are quite meaningful. Along the x-axis, they do quite well in the sense that they have strong agreement with human evals, but they tend to be resource intensive, meaning that there's cost and latency implications of using these evals. However, they provide a nice way to automate evaluations that make it easier to scale rather than simply using ground truth evals or human evals. TruLens and LLM observability at Snowflake provides all of the set of evaluations that we have on this slide, including support for ground truth, human evals, LLM evals, as well as traditional NLP evals and evals based on medium-sized or smaller language models. The traditional NLP evals we find in our experience tend to be quite syntactic. So while they scale really well, the evals are not that often very meaningful. The smaller models used for evals offer an interesting trade-off in that if they're carefully customized and fine-tuned, they can offer cost-effective evaluations, much more so than LLM evals, but they do require a lot of work to work well for specific evaluations. We have spent some time going into the depths of evaluation. The other important component that Avinash had mentioned earlier is instrumentation of applications as well as execution trace logging from those apps. So it's very easy to instrument an app using TruLens, like retrievers as well as generators. So in the code block here on the left, you can see that there are two functions, retrieve and generate completion. These are two of the key steps in a retrieval augmented generation setup. And you can see the annotation on it, the instrumentation of @instrument. Effectively, what that instrumentation does is provide guidance that when you actually run the app, the spans of those traces, the spans of those functions, the inputs and outputs of both retrieve and generate in this case, will get logged along with metadata, which lets us run evaluations later on over these spans, such as context relevance runs over the retrieve span, and groundedness, for example, makes use of both the results of retrieve as well as the final results of complete. We have several upcoming features within Snowflake AI Observability. We are working on integration with open telemetry conventions, SDK and API, to make it very, very easy to work with standard logging, in which you may have logged your app execution yourself, and Snowflake AI Observability can work with that, even if your app was not instrumented with our TruLens client-side SDK. Second, we are working on benchmarking and improving are LLMs as judges. Third, we are working on efficient small model evals that scale better while also being accurate. And finally, we are expanding the scope to cover evaluations for agentic AI applications. To summarize, Snowflake AI Observability offers a very powerful enterprise-grade capability to observe your LLM applications. It comes in two components, a client-side SDK and a server-side component on Snowflake that collectively provides highly scalable, governed, and managed services for observability. We encourage you to sign up for private preview. Several customers have already done so, and you can join us and engage with us in this private preview stage by filling out this form. You can use the QR code to get access to the form and fill it up. We look forward to working with you and are incredibly excited to share Snowflake AI Observability with you. Thank you.